Welcome and hello. This is a lesson in HEC ResSim titled Water Quality Geometry, Connections, Cells Layers, and Met Stations. So we're going to be talking about those three tabs within the Water Quality Geometry Editor in the Water Quality module. Real quick, just to show you where we're starting off, this is my model I've built so far. It's a single river reach with a single reservoir and three meteorologic stations. This is the watershed setup. This is the reservoir network, and this is the water quality module, which I haven't done anything yet. That's where we're going to start. So I'm going to click on water quality and geometry. We're going to create the geometry again. And I know I've done this a couple times in the previous lessons, but there's one thing I do want to point out that is a little bit different this time. So geometry, new. I'm going to just call this geometry 1. It's going to be using network 1. And then for the RAS geometry, this is the cross-section shape file that we created back in lesson 62 of this playlist. I'll leave a link to that in the description where we create HEC-RAS files. Click on import and then navigate to that shape file. So we'll have it saved right here under shape files and open. Now this is the distinction. In previous lessons, for stream station, I selected stationing, and I've had better luck with river stati, like the first 10 characters of the word river station. And I'll show you why that's the case in just a minute. So I'm going to click on river station. I'm still not 100% sure which is best because some of the exports from HEC-RAS may be a little bit different. I'm using HEC-RAS version 6.6 for this particular export, but that could also change. Okay, so river, reach, and river stati, and okay. The last input that's required for a new geometry is the RAS steady flow file. And let me just navigate to that. I have it saved right here and open and okay. All right, so that created my water quality geometry. We see we have our different element names and the element types. First thing I'm going to do is just click on the apply button down here. That saves. And as you see, the display has changed to show the different water quality cells, which it looks like I have 2 per reach, the reservoir, and then a few more reaches downstream of the reservoir for that. So we'll talk about those water quality cells in just a moment. What we're going to be focusing on in this lesson are the connections tab, the cells layers tab, and the met stations tab. What we talked about in the previous lesson was the tabs extent and regions, where you can define specific regions and also modify the extent. So I'll leave a link to that lesson in the description of this video as well. Okay, Connections tab. The Connections tab allows the user to select the upstream and downstream stations for each reach. It also highlights on the map where that reach is when you select it. So CP1 to CP2 right here, if I go ahead and click that, it does kind of zoom me out, but it also highlights that particular reach, which is the upstream-most reach over here. And the upstream cross-section, this one right here, is 127. The downstream cross-section right here is 494. And then the next reach downstream is CP2 to CP3. Sorry, that kind of zooms us out, but it's this one right here. It's now highlighted from river station 494 down to 918. Now, I understand that the river stationing number is backwards at the moment, and I'm talking with the HEC to get this issue resolved. So I just didn't want to wait any longer to start making these lessons because it's already been like 4 or 5 months since this feature has been launched. In the map schematic, you can see that particular reach is highlighted. And if I just go ahead and click on reach from CP1 to CP2, now that is highlighted. We can hold down Shift and then highlight multiple reaches at the same time. If I click off, that will unselect. And if I click on this button in the toolbar for extents and regions, I can draw out a region, and then all of the reach elements within that region are highlighted. If I need to make any changes to the upstream or downstream cross sections, you can see I can do that just by selecting the drop down. All of the options in the drop down here are being read in as the cross section data that's coming from that cross sections shape file we uploaded and created. That's a requirement for the creation of this water quality geometry. All right, I'm not going to change any numbers because it did accurately detect all of the correct connection points for my reaches automatically. So that's nice. I'm just demonstrating that all of these options are the same. One last thing that the user manual mentions about this connections tab, if you're not sure which cross-section that you're dealing with. So say, for instance, you're looking at the map and you want to know which cross-section this is because you want to know the downstream connection from CP4 to CP5. All you have to do is hover, and currently I'm hovering and the little tooltip pops up and shows I'm actually hovering over the junction. So this is the junction information on the map. It says junction CP5, local inflow none. And the same is true if I hovered over a reach. It tells me the name of the reach, CP4 to CP5. I currently don't have any routing or losses, but if I did, information would be provided. And then finally, if I hover over the cross section, the user manual says that I should see the river station of this cross section. You see this green line? I'm trying to get the tooltip to pop up. It doesn't seem to be happening for me. This image right here from the user's manual does have a mouse cursor over a cross section, and you can see it says the river, the reach, and the station number. So I wasn't able to get that to work, but that's something else I may mention and may be addressed in the coming months and future versions of ResSim. Okay, so that's it for the Connections tab. The next tab over in the Geometry Editor is Cells/Layers. This allows the user to adjust the default water quality cell size. You can see there's a frame here in this tab for cell length, reservoir layer spacing, and then finally a button to show table of water quality cells. The default cell size is to use the HEC-RAS defined cross-section spacing. So what that means is it's basically going to take the distance between the cross sections. It looks like it's dividing the cross section into two equally spaced water quality cells. So from CP1 to CP2, we have two equally spaced water quality cells. CP2 to CP3, same deal. From CP5 to CP6, it looks like it's also equally spacing out those two, even though the distance is shorter. So we can take a look at these numbers if we just click on this button, Show Table of Water Quality Cells, and then boom, here is that master table. So for instance, from CP5 to CP6, that is right here, 132 feet and 132 feet. The computation point within the water quality cell is positioned at the center of each water quality cell, or in the case of a reservoir, the center of that water quality layer. So if this is one water quality cell here in blue, and this is another water quality cell here in light gray, then the computation point is actually located at the center of the water quality cell. They do these alternating colors for the visualization of these water quality cells, just so it's a little bit easier to see. And if we wanted to modify the size of these water quality cells, so say for instance, if we wanted a little bit more precision and detail with the calculations, we could make smaller cells. Or if we needed less detail and wanted to have a faster computation, we could make these water quality cells larger. And same is true with the different layer spacing within the reservoir, which we'll get to in just a moment. So let's go ahead and demonstrate how you can change the size of these water quality cells, first along the reach for cell length. To do that, we're going to click on this radio button to adjust cell lengths, and then click on Edit. Now what we can do here is go with a global edit so that the minimum and maximum length for each of these reaches has a specified limit. Or another way is to set the minimum and maximum limit of the water quality cell length on a reach by reach basis. And so let's go ahead and do that. Let's say the minimum is going to be 100 feet, and then the maximum is 200 feet. I could just copy this down. Let's do that for the first three reaches. And then how about the last two reaches? We'll make it smaller. So we'll go 50 and 50, and then 100 as the max and 100 as the max. Now what's going to happen is when I click OK and then click on the Apply button, boom, it looks like there weren't any changes in the first three reaches, but further downstream, it now looks like there are 1, 2, 3 separate water quality cells for reach CP5 to CP6, and 1, 2, 3, 4 separate water quality cells from CP6 to CP7. Now, if you're curious what the actual length is for the spacing, let's click this button to show table of water quality cells. And there's also this filter at the top here. So instead of all reaches, we can just look at how about CP5 to CP6. There should be 3 records here. So it zoomed us out, but that's all right. Here it is selected. The upstream most reach is 100 feet, 100 feet, and then the last one here is only 64 feet. So that makes sense. It's good to see it didn't exceed our specified length of 100 feet. And then CP6 to CP7 which is this downstream most reach right here. That is 100, 83, 100, and 83. So I'm not sure how it's coming up with these numbers, but it did properly enforce that maximum cell length of 100 feet. Okay, so that's how that works. I'm going to go ahead and click on close. In addition to modifying the minimum and maximum water quality cell length in a reach, we can also do the same thing with reservoirs. So the default is 3. That's global for all reservoirs, which means 3 feet of vertical distance in the reservoir pool will have its own water quality cell. However, there's a lot of flexibility here if you select the second radio button, which says value by reservoir. Now, if I had more than one reservoir, we'd see a row in this table, one row for each reservoir. But my only reservoir here is reservoir A, and my options are for the layer spacing to be either constant or variable. Now, if I wanted to, let's see, I'm going to go ahead and check out the reservoir geometry real quick. So I'll click apply, click OK. We're going to head over to the reservoir network. Oh, yeah, of course, save changes. Right click on our reservoir, open the reservoir properties, and then click on the reservoir pool. The bottom elevation is 1350. The top elevation is 1500. So if our layers were only 3 feet, we would have 50 layers, which may be a little bit too much. If our layers were, say, 10 feet vertical distance, we would have 15 layers. If they were 30-foot layers, then that would mean we'd only have 5 layers. So it's sort of up to the modeler to decide the level of detail with regard to vertical distance for each water quality layer within each reservoir. So let's go ahead and just go with a rather thick water quality cell layer size, which is 30 feet, right? So I'm going to go back to my water quality module, open up the geometry, and then select geometry 1. So that's the only one we have so far. Go to our cells and layers, reservoir layer spacing, edit. And if I was going to do this using global, I would just type in a 30 right there. Or if I wanted to do the same thing, but on a per reservoir basis, select constant and then 30. That's the same thing. Now, if I didn't want to do constant and wanted to select variable, for instance, I'd click on this configure spacing. And now it's up to me to specify the vertical layer elevation boundaries between the water quality layers within the reservoir. And remember, this is just for reservoir A. So if I had multiple reservoirs, I could do this procedure multiple times. So the bottom elevation, it automatically starts me off with the bottom of the reservoir pool and then the top of the reservoir pool. But if I wanted to, again, make it 30-foot layers, I would say 1380, 1410, 1440, 1470, and 1500. Maybe I didn't care too much about the bottom 100 feet, so I could just start that off with 1450. Then after that, above that, I may want 10-foot discretization. So I could go 1416, 1417, 1480, 1490, and 1500, something like that. That's kind of up to the modeler to decide, but I just wanted to demonstrate that ResSim allows that level of flexibility. So that's all we have there. I'm going to click on OK. And then here's the water quality spacing table one last time. So we already talked about that. The last tab in the water quality geometry editor that I want to talk about is met stations. So go ahead and click on that. When modeling water temperature, the water quality geometry dataset must be linked to a meteorological dataset, allowing each reach, river, and individual water quality cell to be assigned to a specific meteorologic station. So we haven't talked about it yet, but in one of the next lessons, we'll talk about creating meteorologic stations and meteorologic data sets. I went ahead and already created one. No, I didn't. Okay, I'm going to go ahead and do that. Off camera, I went ahead and created a meteorologic data set called Met Dataset 1. It includes the 3 Met stations that we originally defined on the watershed setup module. So that's right here. If we had multiple meteorologic data sets, they'd be listed in this dropdown. Again, we'll talk about that in one of the upcoming lessons. And next, what we need to do is set a Met station, either Met station 1, 2, or 3, for each of our elements. I'm sorry, not water quality cells, but elements in the extent for this geometry. So we could do that manually just by saying, okay, reach CP1 to CP2. That's probably closest to Met Station 1 or maybe Met Station 2. Let's go with Met Station 1. Boom. And then as for CP2 to CP3, that's kind of a push between Met Station 1 and 2. Let's also call that 1. And then let's see, next up is our reservoir, Res A. That's definitely closest to Met Station 2. I'm just going with the nearest, but there may be reason to select non-nearest Met Station for your particular reach or reservoir. In fact, there's this button right here on the top that I wanted to point out and demonstrate. It will automatically populate the Met station drop-down value for the nearest meteorologic station for that specific element. So if I go ahead and click that, boom, it looks like that populated Met station 1, 2, 2, 2, 3, and 3. So it looks like reach CP2 to CP3 was actually closer to Met station 2, according to the calculations behind that button. So that's how that works. And that is required for when modeling water temperature as part of your HEC ResSim model. So that's it for this lesson. What we talked about was the water quality geometry editor, specifically the connections tab, the cells layers tab, and the stations tab.